Let's imagine walking through a bustling city. Every person there follows simple rules: go to work, buy groceries, meet friends, return home. Yet from these basic behaviors emerges something far more complex: economic systems, cultural trends, traffic patterns, and social movements. That's the essence of emergent complexity, when simple components, following basic rules, create sophisticated and often unpredictable phenomena. Most people struggle with this concept because human minds are naturally reductionist. We want to find the mastermind, the central control, the grand design. When we see a flock of birds moving in perfect synchronization, our first instinct is to look for the leader bird. But there isn't one. Each bird follows 3 simple rules: maintain distance from neighbors, match their speed, and move toward the center of the group. From these elementary instructions emerges what appears to be an orchestrated aerial ballet. The same principle applies everywhere, from how consciousness emerges from billions of simple neural connections, to how market prices emerge from countless individual transactions. There's a profound beauty in realizing that complexity doesn't require complex rules. And colonies don't have a master architect, yet they build intricate structures. The internet wasn't designed by a single mind, yet it evolved into an incredibly sophisticated network. What makes this concept particularly challenging is that it defies our narrative instincts. Humans love stories with clear protagonists and direct cause and effect relationships. But emergent systems don't work that way. They're decentralized, with countless small interactions creating large-scale patterns. It's like trying to understand how a single water molecule's behavior relates to the formation of a hurricane. The connection exists, but it's far from straightforward. People often mistake complexity for complication. A complicated system, like a mechanical watch, can be understood by breaking it down into its parts. But an emergent system, like an economy or an ecosystem, can't be fully understood this way because the whole is greater than the sum of its parts. The interactions between components are just as important as the components themselves. Consider language. Nobody designed English or any other natural language. They emerged from millions of people making small modifications over time, yet they have intricate grammatical rules and subtle nuances. There was no language committee deciding that through should be spelled with 7 letters or that a went would be the past tense of go. These patterns emerged organically. The failure to grasp emergent complexity leads to many misconceptions in fields ranging from economics to urban planning. When people try to design perfect systems from the top down, they often fail because they don't account for the power of emergence. This is why centrally planned economies typically underperform market economies, and why artificial city plans often lack the vibrant complexity of organically grown neighborhoods. Perhaps the most fascinating aspect is that emergent complexity follows similar patterns across vastly different scales and domains. The way galaxies form in space mirrors how cities grow on Earth, how neurons connect in brains, and how ideas spread through social networks. Understanding these patterns doesn't just satisfy intellectual curiosity, it's crucial for addressing complex challenges like climate change, social inequality, or artificial intelligence development. The key to really understanding emergence is to let go of the need for centralized control and embrace the power of simple rules and local interactions. It's about seeing the world not as a machine to be engineered, but as a garden to be tended, where small, thoughtful interventions can guide the emergence of beautiful and complex patterns.